There's a question we have before us today, and the question says, when the root mean squared voltage of a source of electricity supplied is 240 volts, calculate the peak voltage supplied in the alternating current circuit. The question we read from AC circuit says that we should determine the root mean squared value of the voltage if the peak voltage supplied from the electricity source is given as 240 volts. All right, so recall that we established last time that the root mean squared of alternating current is equal to the peak current divided by the square root of 2. So if you write the same expression for voltage, you could write the same expression for voltage, for electromotive force. You could also write it for power supply and so on and so forth. So in this case, we are writing for the voltage. So the V RMS is equal to V0 over square root of 2. Right? So our V0 has been given to us, so we substitute. You bring this value to the place of peak voltage. That means our VRMS is equal to 240 divided by the square root of 2, which should have been the result. But there is still a step further. You cannot leave it in short form like this. Using the knowledge of mathematics, we can rationalize, and then the expression or the equation now looks like. So 240 divided by square root of 2. To rationalize, we multiply the denominator by the numerator and by the denominator. So what that means is that you take the denominator, multiply it by the numerator, and then you also multiply it by the denominator. So if you do this, what you're going to have will be 240 times square root of 2. Then the denominator, square root of 2 times square root of 2, that's going to give you 2. All right, applying indices now. That's going to give us 2 here is 1. 2 into 240, that's going to be 120. So the result is 120 square root of 2. Now it is expressed in volts. So that gives you the value for the root mean squared voltage. I hope you did understand all the procedures and methods. Now, if you have any problem, please do not forget to drop your question. And then I want to receive your feedback. Please share this video so that students in our high schools and secondary schools can also benefit from